Well, greetings everybody. So before I launch into this problem, I want to orient where we are with this. So I've recently made a video on this problem right here on the subject of the linear programming. Okay, so this problem, where I've already made a video to cover it, is about a hypothetical auto mechanic who does different kinds of jobs. He gets paid different amounts for the jobs, and he wants to maximize his weekly income. All right, so I've already done that one. If you haven't seen that one, it might be good to look back at that one for another example. The example I want to do today is the same type of problem, but it's about splitting up investments between a CD and a mutual fund, which have different rates of return. It's the same type of problem, same exact strategy, and if you take all the words out of this and you just look at the math, you really can't tell them apart very much, okay? So what this serves as is just another example of what turns out to be the same thing once you read through all this. Now, if you read this problem, and if you read this one that I'm about to do, then they might appear very different, but we'll use the same strategy. In fact, as I made the slides for the video, I have the same exact sequence of steps and all the same vocabulary and everything. Okay, so before I read it, I will tell you again that this is on the topic of linear programming, and what linear programming is a type of problem where we want to maximize or minimize something. Okay, it could be that we want to maximize income or return on investment, or maybe we want to minimize costs, or there's lots of possibilities, but we want to maximize or minimize something, and there will be constraints that this thing is subject to. Okay, you might think about it. Well, if there weren't constraints on whatever we're talking about, if there weren't limiting factors on it, then the maximum could be anything. I mean, numbers go on forever. All right, there's no largest number. The constraints are what make it such that there is a maximum. All right, okay, so that's the basic format of the problem. When we have a word problem like this, then the additional challenge in all that is reading it and sorting through the information, making sure that we've understood it and know what to do with it. That's of course what makes word problems more difficult. In any case, I think I've tried to lay it out here so that I'm dividing up everything into the most sensible parts, so that we'll read it, I'll show you how I sort through the information and how I turn it into equations and inequalities. Okay, so let's start by reading it. So we have $80,000 to split up and invest in partially a CD and partially a mutual fund. Okay, the CD and the mutual fund have different rates of return. The CD yields 7% and the mutual fund yields 8%. And we'll understand this not as some complicated interest calculation, but just that the CD is going to yield 7% of the investment. Okay. Mutual fund requires a minimum of investment of $8,000. Okay, so I have to invest $8,000 or more. And the investor requires that at least twice as much should be invested in CDs. And maybe because CDs have less risk, I don't know, but that's what it says. Okay. All right, how much should be invested in CDs and how much should be invested in mutual fund? Meaning, how should you split up this $80,000 in order to maximize the return, and what is the maximum return? So step one, as I explain this type of thing, is to read the problem and make sure we understand it and set it up. So I've already read it. I think the understanding part is what you see that follows it. I want to divide it up into these three parts. That I want to identify what I want to maximize or minimize, whatever the case is, because in linear programming problems it will either be to maximize or minimize something. In this case, I want to maximize the return on investment. All right, okay, given that the CD yields 7% and the mutual fund yields 8%. All right, so my constraints are, so what were the limiting factors that we had to take into account? It said I had to invest at least $8,000 in the mutual fund. Okay, all right, and I put at least in red there, I want to make that stand out because linear programming problems involve inequalities. The constraints are in the form of inequalities, which have less than or equal to or greater than or equal to. Okay. All right, so we're going to invest at least $8,000 in the mutual fund. Another thing that it said that would count as a constraint is that we need to invest at least twice as much in the CD as in the mutual fund. Okay, and again, the at least signifies an inequality. Another thing is, this one is buried in there a little bit, that it doesn't say this explicitly, and so that's part of the reason I'm making the video, to tell you this. But if it says the investor has $80,000, we're not meaning to say that this person is going to invest exactly $80,000, but just that we have at most $80,000 to invest. So we're going to invest no more than $80,000 total. Okay, not that exactly $80,000 is what's intended to be invested. So again, I put no more than in red because I wanted you to see that this signifies an inequality. The amount we're going to invest is less than or equal to $80,000. Okay, so I know what I'm going to maximize. I know what the constraints are. And then there are the unknowns that if I'm ultimately going to do math with this, I will have equations and inequalities in terms of variables or unknowns. The unknowns, the mystery in this problem is how much are we going to invest in the CD versus the mutual fund. So I'll say, as I do this, X will be the amount we invest in the CD, Y will be the amount we invest in the mutual fund. Okay, so that will allow me to get equations and inequalities involved in this, which gives me a method of solution. Because otherwise it's just words, right? So far I just have words. I have to turn all this into equations and inequalities, which I will use to solve it. So now that we've taken it to this point, we need to write those equations and inequalities. I want to take this same thing that you see here and write the return on investment as an equation and the constraints as inequalities. So let's look at that. Here's how you would do that. The thing I want to maximize, the return on investment, would be, I'll say R for return. It said that the CD yielded 7%. I remember reading that even though I didn't write it down. Yes, the CD yields 7%, the mutual fund yields 8%. So all we mean by that in terms of this problem is that the return on investment will be 0.07 times the amount invested in the CD plus 0.08 times the amount invested in the mutual fund. That's how you calculate the return on investment. Okay? Alright, so that's what I want to maximize. Now for those constraints. So if I'm investing at least $8,000 in the mutual fund, and if Y is the amount invested in the mutual fund, then I would express that as Y is greater than or equal to 8,000. Likewise, if it said that the amount invested in the CD is at least twice as much as the amount invested in the mutual fund, then that would look like X is greater than or equal to 2Y. So remember, here it is as a verbal statement. Invest at least twice as much in the CD as in the mutual fund. X is the amount we invest in the CD. Y is the amount we invest in the mutual fund. That leads to this inequality. X is greater than or equal to 2Y. And then that last verbal statement that I wrote down was that we're going to invest no more than $80,000 total, so that means the amount you invest in the CD plus the amount you invest in the mutual fund. Add them together, it's got to be less than or equal to 80,000. Okay, so that's everything. Now, when we solve a linear programming problem, then the maximum value in this function, because the objective is to figure out what X and what Y give you the maximum possible value in this function. That answer, that X and Y, will be at one of the corner points of this region if you graph it. Okay? So my next step would be to sketch this out or have some way to look at it, identify what the corner points are, and then see of those corner points which one gives you the maximum value in this function. That's how you solve it. So everything I do from here on is just going to be to do that. Identify the corner points, plug the x and the y of the corner point in here, see which one gives the biggest answer. That will be your maximum. Okay, so here's what it looks like if you graph all those. All right, I get 3 lines. Now on this part I would like to elaborate a little bit. So let's do this way. Let's say this one is from that inequality which said x is greater than or equal to 2y. Okay, x is greater than or equal to 2y. So if I take that and I would like to graph it, then I would do it this way. I would solve it for y and get y is less than or equal to x over 2. Okay, so the way we graph that component of the constraints is I draw the line y equals x over 2, and the inequality signifies, because it says y is less than or equal to, all the points below that. So I might start by saying, okay, I have to take the line x over 2 and graph all the points below it. Alright, so that might be where I start if I was to graph this. But also, I have to, where'd this one come from? See this one? That's from one of our other inequalities. That last inequality I had said x plus y is less than or equal to 80,000. So that comes from x plus y is less than or equal to 80,000. Again, if I aim to graph this by solving it for y, I would get y is less than or equal to 80,000 minus x. So, in addition to this region that I'm working with and finding the corner points for, having all the points below this line, it has to have all the points below the line y equals 80,000 minus x. So again, I would graph this by drawing the line y is 80,000 minus x, and because this inequality from our constraint says y is less than or equal to, then I want all the points below it. Okay, so if I look at each of my inequalities in the constraints, okay, it turns out that what I want is all the points below this line, all the points below this line, and all the points above this one. Okay, that region is this triangular region which has 3 corners. Okay, so my next step would have to be I need to solve for the corner points. I've labeled them A, B, and C. Okay, real quick, I won't solve for all of them because I've talked about how to do that in other videos, but maybe let's solve for B. Like, how would you figure out where this corner point B is? That corner point B is the intersection of the line x over 2 and the line 80,000 minus x. Okay, so you would solve for that by setting these equal to each other. That's the procedure as explained in other videos. So x over 2, okay, and then I need to set that equal to this other equation, 80,000 minus x. Okay, if I add x to both sides, I'll get 3 over 2 x is 80,000. Okay, and then if I multiply both sides by 2/3 in order to solve for the x, I'll get 160,000 over 3. So for that point B right there, where this line and this line intersect, the x coordinate of that point is 160,000 over 3. How do you get the y coordinate? Well, you can take the x coordinate that you found and plug it into either equation to find the y coordinate. Because, you know, for each of these equations, you plug in the x, you get the y. All right? Okay, y can use either one. See this one? I could use this one, or I could use this one to find the y coordinate. You can use either one. Why is that? Well, because that point is on this line, and it's also on that one. So if you plugged in the x, you should get the same y either way. If you do that, you'll get 80,000 over 3. Okay, so that's how we can find the point of intersection. So I've got my corner points. Now, where we go from here is if you want to know of all possible values in this problem, the one, the x, and the y that makes this the biggest, it has to be at either point A, B, and C. Okay? Alright, so where we take it from here is we just test each corner point in the return on investment function and just figure out which one's the biggest. So that return on investment function was r equals 0.07x plus 0.08y. Plugging in points A, B, and C into that function gives me these three numbers. Those are all in dollars. And then this one's the biggest. So you'll find your maximum at point B. All right? Just because that's the biggest number. And there's no other reason for it than that. Okay, so that's all we have to do in step 3. Step 4 is to make a statement of your answer. So let's see, how would we take this and formulate it into an answer? So the x coordinate was how much we invest in CD, okay? And I got this number when I solved it before. I got 160,000 over 3. But if we want to round that out at some point, that's 53,333 if you round to the nearest dollar. So that's how much we want to invest in CD. The y coordinate was how much we're going to invest in the mutual fund. If you take 80,000 over 3, you'll get 26,667 rounded to the nearest dollar. That's how much we invest in mutual fund. And that will give you your maximum possible return of all possibilities in this question of $5,867. Okay? So that's how we do it, and that's this answer up here. So I've taken this as a screenshot from MyMathLab, but there are the numbers that I got down at the bottom of the page when I solved it. Okay, so that's how it's done. I might say from here that if you see other problems that read a little bit different than this, they may sound different because they have different words, the scenario's different, but still, like, they will all be understood in the same sequence of steps. You can go through it, write down what you want to maximize or minimize, write the constraints down, write the unknowns down, just as I've started off, and then proceed from there.